So this demo is a demo of SlyFi, our privacy-preserving link layer. So this is something like Wi-Fi or 802.11, except that it's built to have better privacy guarantees. So here's a map of Seattle. And over there is my laptop, my Intel-issued laptop, that has all of the latest, greatest security features in it. The laptop is going to scan and try to find a suitable network. This demo is sniffing the traffic in the air and looking for any networks that are trying to be discovered, and then taking the names of those networks, looking them up in an online database that has the latitudes and longitudes of many of the networks in the country, and then graphing it. And so you can see some of these networks are pretty straightforward. Like, this is the University of Washington CSE network. Since our lab has collaborations with the University of Washington's computer science department, that's not a surprise. It might be a little bit more of a surprise that Cafe Solstice is one of my networks. That happens to be a cafe that I spend a lot of time at. Maybe more alarming is DJW, which happens to be the initials of our director, David J. Weatherall. This information that my laptop is broadcasting can be used to figure out where I've been in the past. A little bit frightening. So the problem is that anyone with a laptop and free software can intercept our transmissions and find identifiers in our transmissions that give away who we are, where we go, and who we interact with. So for example, this is what Wi-Fi, this is a packet that Wi-Fi sends to try to find another network. It's called a probe request. And in it, it contains the name of the network it's looking for. In this case, DJW, David J. Weatherall's initials. So anyone can read this in the clear. So what we've designed is a new protocol that conceals all of these bits from eavesdropping third parties. To them, they look random. To the intended recipient, they're as easy to read as this. So here's the same packet sniffer running on our new protocol. And in this case, all of the information has been scrubbed clean. So the goal is to encrypt all of these bits, which seems straightforward enough, but the protocols as they've been designed in the past rely on these bits to be sent in the clear. So we had to figure out how to encrypt these bits, still make the protocol work, still make it work efficiently, and not change the way it's used at all.